Alright guys, we're back. We're gonna finish this video series up for Unit 2 with average atomic mass. This is attempt number 4 at this video. Let's see if we can get it done this time. In nature, most elements are mixtures of different isotopes. Okay? Remember, isotopes have a different number of neutrons, but they are the same element, so they have different masses. Okay? So, because of that, we want to get a weighted average to get the mass, the average atomic mass. So the mass of a sample of an element is the weighted average of all isotopes in the sample. So what is this? What is a weighted average? Well, your grades in class are a weighted average. So you have 30%, that is your labs. You get 30% for daily work, and you get 40% for your tests. So let's say you end up with a 0 for labs because you don't do any. You get 100 for your daily work, and you get 100 on your tests. The highest grade you can get in my class at that point is a 70 because you are missing 30% of your grade. That is the same idea as what we're going to be working with in the average atomic mass. So let's refresh our memory about what is on our periodic table. You get the atomic number, the symbol. This would be carbon, and it has a average atomic mass of 12.011. It is a weighted average of all the isotopes isotope masses in the that appear in nature. So which one do you think it's closer to? Carbon. Which one of these isotopes, carbon 12 or carbon 14, which one do you think it's closer to or has more of it? Let's say which one has more in nature, 12 or 14? Hopefully you guys can see that 12 is closer to 12. Okay, so there's more of them. How does this work? Well, when you're calculating average atomic mass, let's take this chlorine atom or this chlorine isotopes for a minute. If I have the element chlorine and it has two naturally occurring isotopes, which are chlorine 35 and chlorine 37. And I think I told you in an earlier video when I did the hyphen notation that you might not see these very often, where they just have the symbol and the mass. Remember, this is the symbol, and this is the mass number. Right here, these are mass numbers for the isotopes. I told you we probably wouldn't see these. I was mistaken. I apologize. I wasn't thinking. It's late and I wasn't really thinking clearly. So let's pretend we have these two isotopes that occur naturally in nature. Which isotope has more neutrons? Would it be 35 or 37? Hopefully you said 37. How many more? Well, if we have 35 as a mass number here and a 37 here, remember that chlorine 35 has 17 protons, and chlorine 37 also has 17 protons, and you subtract, you should get a difference of 2 extra neutrons, because this number here would give me 18, this would give me 20, and the difference is 2 neutrons. Okay, so calculate atomic mass. Let's take, for instance, we have those two isotopes, 35 and 37 of chlorine, and in nature, I have 75% of all chlorine atoms in nature would be 35. 25% is going to be 37. 25% of it is going to be in the 37 isotope. What is the average atomic mass of a sample of chlorine? Well, here's what remember, this is weighted, so most kids want to do this. Okay? well, take that back, scratch that. I'll come back to that in a second. Okay, so out of 100 atoms of chlorine, that means if I have 75%, I have 75 that are at 35 AMU, 25 that are at 37 AMU. So, well, here's what most kids want to do. 35 plus 37 gives me 72 divided by 2 gives me 36. Okay, well, here's what happens. The unweighted average for this is 36. This is not our answer. Okay, this is not our regular average. Remember, it's a weighted average. And so a weighted average is calculated with this formula. Memorize this. It'll also help you if you want to know what your grade is. Okay, so your mass of the isotope times your percent. So let's say, okay, so our mass was 35, okay, and then it's going to be multiplied times 75%. Well, what we're going to do with this percentage is we're going to turn it into a decimal, 0.75. Okay, don't forget your parentheses. We're going to add that to the mass of B. So the mass of B was 37, and the percentage was 0.25. Remember, it has to add up to, oh, that's a multiply, times 0.25. Okay. Remember, it's got to add up to 100, so we're going to divide all of this by 100%. Okay, 100. Or, I'm take that back. We're going to divide it by how many we have, or how much we have. So, we do all this math here, and we get a 35.5 AMU, which if you look on your periodic table is very close. I believe the mass on the periodic table is 35.453 for chlorine. So these two numbers are fairly close, right? So let's take another one. Let's try this one. Okay. All right, so let's take this. We have copper 63 is 69.17% of all copper atoms, and then copper 65 is 30.83%. Is the average atomic mass 64? No, because that would be unweighted. Okay, so let's go ahead and try this one. Let's set this one up before I change the slide. Okay, so we're going to take the mass of isotope A. So let's take the mass, which is 63. Again, here's where I'm getting my number, right? These are the masses right here. I'm going to multiply that times the percent, but in a decimal form, 0.6917 plus, and then we're going to put 65 times 0.3083, okay? And you over 100, okay? So, will the weighted average be closer to 63 or 65? Which one do you think it is? Think about it. I got 69%, almost 70 to 30. 63. Why? Because 63 has almost 70% of the average. Okay, so your answer should be that. I would like for you to come up with the answer and bring it to class, the actual answer to this question here. And you guys have a good night.